Hi and welcome to this introduction to enterprise AI agents. In this presentation, we will first align on defining what AI agents are before getting into the specifics of designing good agents and using them for the right use cases to ensure that we get the most value out of it. To set your expectations, this presentation targets executives that are not at all aware or just somewhat familiar with AI agents. So, to start, let's first define what we're talking about. What are agents and what are they good for? Typically, if you would think of defining something, you would go look up a definition. If you look up agent definition, it's sort of a philosophical concept that talks about a capacity to act and the ability to exercise this capacity. Maybe that makes sense to philosophers, but that kind of doesn't really do it for our context, does it? I don't know what to do with this. Let's maybe look at an example of what an agent might be in real world. This is a short video of this agentic system called Manus AI. It's similar to open AI agent called Operator. In this case, there's a person who is logged into Manus and they want to purchase a property in New York. I care about Prime. I have 2 children. I care about access to schools. I make that much a year. Can you go find me properties that I can look at? Manus then creates a task list for itself. A research plan opens up a browser. It has access to a computer. It goes and searches through all of these various websites, collects information, makes a plan, executes according to that plan, on and forth until it's finished by building up a collection of properties that you can look at and gives me an overall executive summary with recommendations. This is a good real-world example of what an agent or an agentic system might look. Now let's go back and think about the question of what agents are. And you might think, let's ask the big tech who have introduced this concept of the world. How do they think about agents? The problem is that even when we ask big tech to define this, it is still a confusing proposition because depending on who you ask and when you ask them, they might have different definitions. For example, OpenAI talks about multi-step tasks. Sam Altman himself talks about actions to achieve goals. Anthropic has a computer use space definition. Dario Amodei has his own definition which is around goals. And then Google has a thinking which highlights thinking more than others. You can see everybody's coming at it from different angles, which makes our job a little bit difficult. But what we'll do is for this session, we'll try to tentatively agree on a working definition of an agent. What I propose for the sake of this presentation at least, is that we accept that an AI agent is essentially a program which is capable of acting in an environment. This could be a digital environment, a physical environment, and on to fulfill a goal. As long as we take this definition of agents, we are good to start with the rest of our discussion. However, the definition and an example might not be enough. To sharpen our intuition, we should think about breaking some myths and looking at some examples and counterexamples. One question a lot of folks might have is, are agents essentially large language models? And the short answer to that is no, they're not large language models. In fact, they are systems which are much more than large language models. In a typical example, you might compare, say, ChatGPT.com, which is more of a chatbot versus operator, very similar to the Manus example that we saw. One is an LLM, the other is an agent. What does that mean? Why are AI agents different from large language models? Agents use large language models, but they also do a lot more. Essentially, because large language models are only language generators, they do not have enough capabilities and affordances to be able to exhibit goal-driven behavior. But there are some things that we can add to large language models to get them to doing that. And that's a little bit of what we'll talk about after looking at a few more examples today. What are vanilla large language models able to do? They have general word knowledge. They have the ability to generate language. They have some generic logical reason where they lack is, their knowledge is baked into their weights. They are not by themselves able to act on their environments. They are completely important in the sense that whatever happens in a session is completely lost. They don't have any concept of short or long-term memory. Because of this, any kind of processing, they can do a single-step stateless and on and on. A lot of more complex behavior is of course limited because of all of these restrictions. Some of you may have also thought of tools or may have heard of tools and you might be thinking, are agents some kind of smart tools? And the intuition here as well is that they are not smart tools. They are quite a bit more than tools as well. Now, to sharpen this intuition, let's look at what may be tools which are not immediately agents. Tools can be your traditional programs, a calculator, a calendar in case of Manus.ai, as you saw, a web browser, and now with Operator and Anthropics and computer use, etc., we are getting to a point where LLMs are becoming more and more efficient to use entire computers. These traditional programs can be tools. Various kinds of databases or web services can be tools. Something that you may not have thought of, traditional machine learning models can be tools. You can teach AI agents to use traditional ML models, forecasting, optimization, recommendation, and so on. Even LLM tools can even be based on large language models in the sense that they have predefined steps or predefined processes with not a lot of independent decision-making going on. If you have an LLM prompt which takes a text in English and, say, converts it to Spanish, that's a tool that an agent can use, summarization, classification, and so on. These are all examples of tools, but they're not agents. Agents, as we can see, are more than tools. However, because of the noise in the market, sometimes you may have smart tools or workflows being marketed to you as agents. You may see an example of a translation tool being marketed to you as agents. That's an example of the noise that we would want to cut up. Now that we give large language models tools, what are these able to do along with the things that we already had? We are now able to expand the knowledge base that the large language models have by connecting them to our databases, whether they be vector databases, SQL databases, or knowledge graphs and on. We are able to expand how much of our lives and our businesses they know about. And also we are able to ensure that they are able to take actions. For example, they can connect to your database systems and update records. They can connect to your shipping systems and make purchases or fulfill invoices and on and forth. They can actually act in the digital physical world. However, as we saw earlier, there's still things that they still lack. Now, another concept or idea that you may have heard of is this concept of memory, that agents are supposed to have memory, and is that true in all instances? This one, in fact, is actually true in all instances because remember we were talking about getting to goal-driven behavior. And goal-driven behavior necessitates the existence of some kind of state, and state comes from memory. And to that point, memory itself can be of various different kinds. They can be short-term memory, medium-term memory, or long-term memory. To give you some examples, short-term memory might be the context of a single conversation, some sort of past actions taken. This is something that might be useful for a shopping agent, similar to the Manus.ai example that we were looking at earlier. It created a plan and then it sort of looked back at what it did against that plan. Long-term memory can be, for instance, something a digital therapist might use. It can know certain things about you, know how you meet to the agent, know what kind of experiences you've had in your life and on and forth. And I can use them to improve my ability to interact with you. And then they can even be persistent memory. These can be things: what are my overall system goals? What are my overall system guardrails and strategies that I have access to? And these sorts of things might be used by, for example, stock trading agents. All agents have memory, and what now memory allows us to do is it gives us stateful multi-step behavior. It allows us to expand our context windows because we don't have to stay limited to the context that we had. And this is a smaller problem today now that we have much larger context models, but it used to be a much bigger problem when we had short context models. And we have access to all kinds of different memory ranges. However, there's still things that we may not be great at, but there is a special kind of memory which is related to this idea of planning. If you think of a plan as a special case of long-range memory, then it immediately gives us access to a whole new set of capabilities because I can reflect on what I'm doing against my planned course of action and course correct. I can have information about what my goals and values are and sort of come back to them when I deviate. I am able to also keep tracking and aligning myself to my goals and values. Because of the ability to plan things as a special case of memory, I'm able to do a lot, but I still am probably improving but not fully able to solve with long-range and complex problem solving. Let's have a quick recap and think about what we have learned so far about AI agents. We said an agent is something which has a brain, which could be an LLM which provides it general knowledge, general reasoning, and language generation ability. On top of which we may add tools which gives us the new knowledge as well as the ability to influence its environment. On top of which we may imparted memory and planning which allows it to show stateful behavior and goal orientation. Now that brings us back to the definition that we talked about earlier, and we can see how we get to an agent, which is a program that can act in an environment to fulfill a certain goal. However, this might not be sufficient to solve a lot of our complex and long-range problems for which we might need not one agent, but essentially systems which employ multiple agents, which might improve the ability of these systems to do complex problem-solving and long-range problem-solving. And we'll see an example of that. However, we have to still remember, at least for the current state of things and the near foreseeable future, they might still lack human intuition and ingenuity, but we're making rapid progress in that direction as well. When we talk about multi-agent systems, there's no set pattern as to how you build these multi-agent systems. There are various topologies that multi-agent systems might be organized in, some of which are better than others depending on the nature of the problem that we're trying to solve. Now that we understand what are single agents, what are agentic systems, which might be a combination of multiple agents and other tools and knowledge spaces and on. Another distinction that would be useful to think about is that agentic systems can span a spectrum between being a co-pilot or a helper to being an autonomous dual agent. The co-pilot word was popularized by Microsoft is something that we all understand because this is really the modality in which we all started engaging with these models, and co-pilots are essentially assistants. It's a very hands-on, interactive experience. Even though we may engage with them in different modalities, these are typically low-latency, highly contextual kinds of agents or assistants designed to augment human productivity. But on the other hand, we have the autonomous systems. These are systems which may serve in the background and not interact with humans at all. In certain cases, they may be triggered by a human action, or they may be triggered by another action but produce something for a human to consume. But they can also be fully autonomous. Imagine you had an autonomous IT operation system which detects a problem and takes care of it without a human ever having to get involved. They can be good for both low as well as high latency processes, and they can augment both human and machine productivity. They can be, since they're fully autonomous, more risk-prone, especially if you're automating large chains of work. These errors can accumulate and magnify over this decision-making, etc. And this side of the spectrum, since it started improving later than the interactive side, is improving rapidly for trailing behind the first side of the spectrum. Let's get into the question of how do we design good agents. There are a lot of different principles. We've chosen these 5. Each of these is a composite principle in the sense that it's not unidimensional. These are multidimensional principles. But goal alignment, purpose will, goal alignment, inclusivity and user centricity, transparency and accountability, secure and robust, governed and iterative are 5 very critical examples of good design principles that we should follow. And I'll take a few quick examples to make this real. Imagine what if we have an agent which decided that it's going to offer digital coupons to users to encourage our direct-to-consumer purchases. An example of an aligned goal or a well-aligned agent would be it wants to maximize long-term value while protecting margins for the business. An agent this would think carefully about what discounts to offer, which segments to offer these discounts to. It will improve margins and on. A misaligned goal for an agent in this case would be we're only thinking of conversion. Such an agent might offer very large incentives. It might train the shoppers to wait for deals. And overall, while it might increase sales, it might reduce margins. And in some cases, if you are playing in the premium segment, maybe even corrode your brand perception. This is an example of why thinking about alignment is important. And one sort of mantra you might want to use is you want to think of alignment as imparting values to a child on how to make decisions. And you want these values to be gentle enough that they would work even when an agent is faced with unexpected and unforeseen life situations. That's one way to think about goal alignment. Another example for thinking about inclusivity and user centricity is if we had a voice agent which provides guidance to your customers on how to build new recipes with the food brands that a company offers. And a well-designed human-centric agent, or at least one dimension of it would be that it's been trained to understand accents, understand cultural cues across various different parts of the demographics. And it uses responsible and empathetic language without being sycophantic, which is a criticism that OpenAI recently drew for making their models too sycophantic. This would lead to improved brand engagement, and product sales. A not well-designed agent in this case would be, let's say, an agent that's trained on primarily US male voices and tends to misunderstand when women are speaking or other ethnicities are speaking. This kind of thing can erode brand value, reduce the effectiveness at selling, and so on. Another way to think about it is you are thinking of expanding your office with new digital colleagues. You would want to give all of them the best equal onboarding experience, and you would want all of them to be kind and nice to everybody else. And that's one way to think about when you're thinking of inclusivity. The third critical principle here is on accountability and transparency. Again, let's review an example. What if we had a social listening response agent, which is monitoring social networks and responding to customers on those social media? A transparent and accountable agent in this case would have been designed such that it creates a response which is validated by a human being. The response clearly states that the responses from an AI reviewed by a person, it takes the responsibility of following up on any inputs from the humans, from the customers, and then resolves the issue. It takes itself seriously the responsibility of being accountable and transparent. An agent which is not well aligned to this design principle would be frivolous in nature. It may fail to disclose that the response is coming from an AI. It may hallucinate and provide incorrect resolutions. It might even make promises on behalf of the brand or use language that is not well suited. And there have been examples of this in the case of an airline company and courier companies from the UK who have gotten into some of these reputational concerns. On trust and accountability, the way to think about it, at least in my view, is you wouldn't want to work with a human coworker that you did not trust. You would expect at least the same, if not more level of trust from an AI agent. And the way to build that trust and accountability is through being transparent and honest. Moving to the next principle, security and robustness. What if we had a promo planning agent which helps financial managers to decide what's the optimal promo spend? A secure and robust agent would make sure that any data being uploaded has the schema. If there are any problems, it informs the user and does not use inappropriate data. It makes sure that one employee is not able to see data that only other employees should see, etc. Whereas an agent which does not have such a robust security stance may end up accepting inputs which are malformed or in some cases even malicious due to lack of responsibility or lack of training. It might trigger code execution which may be insecure for the organization. It may lead to folks who should not see a certain data being able to see that data and on and forth. And this would be another situation where even though the agent may be capable of doing the task that it needs, the way that it is designed and implemented is not fit for use. And in this case, again, you want to think of agents as a new kind of workforce. And even for our human workforce, we make sure that we have enough information security and guardrails to govern their behavior. And we should have the same principles apply for AI agents in the workforce as well. And lastly, the principle of being governed and iterative. Here we can consider the example of an insights analyst, which helps commercial insights teams to run queries, build reports. In this case, a well-governed agent would start with small steps. You would iterate based on previous experiments and pilots, making sure that humans are able to verify the information and revert these versions in case they create incorrect information. This kind of system may lead to a high confidence, a higher adoption, personalized insights, and a stronger halo effect for adoption of AI for new scenarios. Whereas a poorly governed agent might be rushed through without enough personalization, without anywhere enough verification and evaluation, and without the version controls being set in, which may lead to users ending up making incorrect decisions due to incorrect insights, the inability to audit the source of these mistakes, and overall leading to reduction in the willingness of the organization to try AI-led innovations in critical use cases. If you think of agents as a new kind of workforce, this applies the same principle that even for our human colleagues, we have managerial oversight, we have remedial measures, and we need to establish the same kind of digital oversight and remedial measures and the ability to revert for agentic systems as well. The next section is how do we pick the use cases? The way we think about this, enterprises make a myriad of decisions, and we think of these decisions in terms of operational to tactical to strategic. And there are a few different dimensions which might define what buckets these decisions fall in. Are these decisions occurring or one-off? Are they easy to frame or difficult to frame? Small impact, small risk, high risk. And also these dimensions themselves are again multidimensional. Impact is something we'll talk more about, has a lot of different aspects to it. Risk has a lot of different aspects to it. And to give you examples, the way we think about is operational decisions as the agentic technology matures more and more would get pushed more and more to AI experts with humans essentially playing the role of oversight. This would lead to the current workflows being more or less essentially broken down and reconfigured overall to give rise to new workflows entirely, which are designed and optimized for AI experts and AI agents rather than human beings. And pricing and promotions is one example of this. In tactical decisions, we feel that humans and AI agents would sort of go hand in hand closer to the 50-50 split. And new workflows will have to be designed for both of these entities to be able to take over from each other as and when needed, as well as being able to inform and modify the parts of the other. An example of this could be a new product launch from our consumer goods company. And an example of a strategic decision would be something a merger and acquisition. And these would continue to remain in the camp of humans, making these decisions, but with a lot of augmentation, a lot of support, fact-finding, bouncing of each other. That's how we sort of think about how these decisions might play out. Based on some of those examples, where are we today in the world? We can think of a two-dimensional matrix where we have risk on the x-axis going from high to low, and we have value going from low to high on the y-axis. And we can sort of break down the world into safe bets, which is low-risk, low-value stuff. And almost everybody is currently doing proof of concepts. A lot of these POC have proven successful, and we're doing pilots now and thinking about how we're going scale this up. Then of course we have the low-risk, high-value stuff and the high-risk, but high-risk, low-value stuff, which is again POCS and MVPS going on. But of course, with an eye on the profit catalyst, I think what everybody is thinking about and wishing for is the bold innovation spectrum, which is high-value, low-risk. But this is something where more people are watching for social proof, waiting to see where this technology ends up because it's progressing rapidly in a way that's almost a deflationary currency. To a certain extent, people are saving up to see when do they start investing. But we think that more and more of this is going to start becoming real in the next 6 to 12 months because the technology is improving very rapidly. Let me talk about how to get value from agents. On the question of value, at Fractal, we follow this value-backwards problem-solving strategy. Most of the world today is thinking about, okay, I have this tech, what can I do with it? We think the way to think about is to go back from where am I seeking the most alpha and how do I make this technology go there? That value might come in terms of either reduction in time to speed of decision-making, reduction in cost increase, increasing the revenue, or improvement in the quality of the decisions and outputs and production, keeping everything else constant. Keeping that in mind, this is the framework, the value discovery framework that we use and we encourage our clients use is to start from a value discovery process where we think about what's my opportunity, what are the levers in terms of revenue, cost, time, quality that I can extract value in, who are the people that I need to get on board. And once I have the value mapping figured out, then again, we use A to left framework of thinking about what's the data I need. What's the AI output I need to generate for me to be able to do that? What is the tech that I need to enable? Once I have the tech ready, how am I going to make adoption happen in the org that they can start using this thing and it changes their ways of working? And then once folks have started using these new technologies, how do I mitigate any risks that might come with it as well as governing them properly? And these are this is how we suggest enterprises yourselves think about investing into agentic AI with a portfolio of use cases. I will close this presentation with one example of a company which decided to use agents. In this case, it was a mix of deep reinforcement learning agents as well as generative agents being used to optimize the production throughput in their packaging facilities. The problem is that we have these packaging lines within a factory, and these packaging lines have this trade-off between making sure that if you're saying a product has N grams of product, it must have N grams of product. But every little bit of overage above N grams is something that I want to minimize. But at the same time, if I try to minimize this waste is too much, I am reducing the overall throughput of this packaging pipeline. Typically, these assembly lines are controlled by machines which are operated by humans who would maybe come and set and forget it at the beginning of the day, maybe doing a check-in once or twice during the day. What we were able to do with bringing in agents is we were able to hook into all these systems, collecting machine data and training these models to be able to look at this at the interval of a few minutes and keep adjusting the throughput. And because of that, we were able to, through a test and learn-based design of experiments, we were able to prove that we could get anywhere from 5 to 13% efficiency improvements by offloading this kind of task from human beings to these AI experts, as we talked about. Those agents, we tried this out and are already projected to generate $200 million in additional profitability over a period of 3 years. These are the examples of use cases where by removing certain cognitive locks on the ability and the bandwidth of humans by introducing the kind of AI experts to augment them, it can generate a lot of value. Working back from that value is probably the best way to think about how we find those use cases and how do we go after enablement, risk mitigation, and on and forth. Thank you.